In this video, we're going to find a quadratic function given some properties. Specifically, we're given this graph, and I see two distinct defining points on this parabola. One is the vertex, and this other one is the y-intercept. Now, because I'm given the vertex, it's very clear I'm leaning towards vertex form right now. And then what I could do is use this second point to help me find out a little bit more information and complete the vertex form. Some other options for quadratic functions are a standard form or general form and a factored form, but I don't have enough information from the graph alone to pursue those forms. So vertex form it is. All right, so let's start with the vertex form, which looks like this, where x and y are our variables. A is that stretch or compression or flip factor, and h and k are the vertex. Well, we were given the vertex, that's 3, -12. So here h is 3 and k is -12. So I'm going to first substitute those values. H is 3 and k is -12. Now notice in the vertex form there's a subtract h, so I keep that as x minus 3 whenever I substitute that value. Now here I still don't have the full vertex form. I still need to find out what a is, and this is where that second point will help us out. So we know that this point makes the equation true, and it is an xy ordered pair, so we're going to substitute 0 in for x and -3 in for y and solve this equation for a. So let's see, here we have -3. When we square -3, we get 9. We'll add 12 to both sides, divide both sides by 9, and we get that a equals 1. So at this point, we can write y equals 1, or just the understood, x minus 3 quantity squared minus 12. And this is the vertex form of that graph. It is the quadratic function that describes the graph. And it will be accepted inside of my math lab because we're just told to type an expression. We're not told that it has to be in a particular form. Now, if you want to take that a step further and put it in that more standard ax squared plus bx plus c form, that means I need to do some more algebra. All right, so that algebra involves squaring this binomial. That's going to become x squared minus 6x plus 9. I'll bring down the minus 12, and then I combine like terms where I can, and I end up in standard form, y equals x squared minus 6x minus 3. That is also the quadratic function, just in a different form. I like that this confirms for me the y-intercept that we see in standard form is -3, and sure enough, the y-intercept on the graph was also -3. But because of the way it's worded here inside of my math lab, you could type this form or this form. Both will give you the correct answer.